Okay, guys, here they want us to use Gaussian elimination to solve the system of equations, right? And to be more exact, they want you to use Gauss-Jordan. Basically, we have to get the identity. So the goal is this. Let me fix that for you, make it look better. So the first thing I have to do when I'm using Gauss-Jordan elimination method, I need to write the system of equations as an augmented matrix, right? So we need to write it as an augmented matrix. This is the first thing I have to do, okay? So now what we need to do next is just rewrite the system of equations, as I mentioned before, as an augmented matrix. So we take the constants of each variable. So here we have 1, 3, 4, 2, 7, 3, 2, 8, 6. And we need to put the right side of the equation, right? Which is 3, -7, -4. So as I mentioned before, the goal is to have on the left side of the matrix, I need to have the identity. That's basically the goal. So the first thing I should notice when I'm doing this system of equation is if this pivot, right, which is the first non-zero element in each row, if it's 1. If it's 1, I'm in good shape because that allows me to get rid of these elements here. For example, I can get rid of this element and this element. And usually that's what we do. We want to get rid of those two. As you can see in the identity, we have 2 spots for zeros, right? So that's the first thing I usually do when I'm solving Gauss-Jordan elimination method. I try to get rid of those two numbers first, or those 2 entries, right? In the second row and in the third row. So what I'm gonna do is I'm gonna do multi-step, right? I'm gonna get rid of those 2 simultaneously at the same time. So I'm gonna multiply -2 row 1 plus row 2, and this will give me the new R2. And the same, and for the next operation, I will do -2 row 1 plus row 3, and that will give me new R3. Okay, that's what I will do. So first, let's take care of the red part first, which it says -2 R1 plus R2 will give me the new R2. That means that row 2 is going to change. Everything else will remain the same, right? So I have to get rid of this. So when you compute that, you do -2 row 1. So row 1, the elements in row 1 are 1, 3, 4, 3, right? So I need to multiply -2 times those elements, right? Usually when people, they do this system, this Gauss-Jordan elimination method, just in case, right? People, they do this. It's not important, but people, they just do like this. They do it backwards, and they, just to let you know, it's, that means the same thing, but just to let you know. For me, it's easier to think about, oh, what number I'm multiplying first, okay? But that's the same thing. Okay, so we need to multiply the first row by -2. So -2 times 1 is -2 plus 2 is 0. -2 times 3 is -6. -6 plus 7 is 1. -2 times 4 is -8. -8 plus 3 is -5. -2 times 3 is -6. -6 and -7 is -13. I think you can do that computation on your own, right? Now, like I mentioned before, I'm gonna do 2 at the same time to save time and space too. So now what's changing is row 3, everything else remained the same. And these 2 matrices, they're equivalent to each other, right? So I need to multiply -2 times row 1 plus row 3 will give me new R3. So the only thing is changing, once again, is row 3. So -2 times row 1 So -2 times 1 is -2 plus 2 is 0. -2 times 3 is -6. -6 plus 8 is 2. -2 times 4 is -8. -8 and 6 is -2. -2 times 3 is -6. -6 and -4 is -10. So that's what I have so far. I hope that makes sense. Now, my next goal, so I'm doing this by parts, right? My first goal was to get zeros under that 1 on the first entry. So I'm talking about this, right? These things. So I already got my zeros there. So that was my first target. Now my second target is to get rid of this guy. I want to get rid of that. And then after that, I will have my third row. I will have 0, 0, and whatever that pivot will be. It doesn't matter if it's 1, 2, 3, whatever. As long it's not 0, the system is still consistent, right? Because if I have 0, I will have either the case that I have infinite number of solutions, or I will have the case that I will have no solution. So in order for me to get rid of that element, right, I will multiply the row 2 by -2. So I'm doing -2 row 2 plus row 3 will give me new row 3. Okay, so what that means is that everything else will remain the same except the row 3. So let me do that. So let's do that, right? So -2 times all the elements in row 2. So -2 times 0 is 0 plus 0 is 0. -2 times 1 is -2. -2 plus 2 is 0. -2 times -5, it's +10. +10 and -2 gives you +8. -2 times -13 is +26. 26 and -10 give you +16, right? So now you can see what's the next step, right? So now my goal was, remember, I want to get a 0 here, right? And I achieved that target step, right? Now, since these two are divisible of each other, right? I can divide or I can multiply 1/8 times row 3. So that's my next step, right? So I will multiply, give me 1 second. I will multiply 1/8 times row 3, and this will give me new row 3. Okay, so everything else will remain the same. So let me do that. Everything else will remain the same except row 3, right? So I have to erase this and do the arithmetic, right? Operations. So 1/8 times 0 is 0. 1/8 times 0 is 0. 1/8 times 8 is 1. 1/8 times 16 is 2. And let me change the color because I put that in purple. So I want to stay consistent with that. So this is that, right? Okay. Now, as you can see, I have my elements. My last row, I have 0, 0, and 1, right? So now this is in row echelon form, just in case you're still confused with those, with the vocabulary. So this is row echelon form. Yes? So now I have everything in row echelon form. Now at this point, you can do back substitution, but you have to read the instruction, right? You have to read the direction, what they want here. They said they use Gauss-Jordan elimination method. So I have to do everything using this method, right? So I need to go back to the problem. I cannot just say, oh, I'm gonna use back substitution, because that's not what they're asking. They're asking to use Gauss-Jordan. So that means right now I need to get zeros here in these positions, right? I need to get zeros there. And once I get zeros there, I will get the identity. So I need to get rid of those guys. But at this point, this computation will not be that difficult. Now, in order for me to get rid of, what I usually do is, since I have a 1 here, I'm sorry about that. Since I have a 1 here, 1, I can multiply the row 3 by 5, and I can get rid of this guy right here, right? And then if I multiply by -4, I can get rid of this guy right here. So that's my next steps. Usually that's what I do. So my first step right now is that I'm gonna try to get rid of that -5 in row 2. That's my next step. Therefore, let me let me copy this. Okay, so let's do that. And as I mentioned before, my next step is I want to get rid of this guy, right? And in order to get rid of that guy, I need to multiply my row 3 by 5. So let me put that in green. So I'm doing 5 row 3 plus row 2, and that will give me new row 2. And let's do 2 steps at the same time, just to save time and space, right? So this doesn't become like a problem that takes forever, right? So the next step will be get rid of this guy as well, right? This guy right here. So in order to get rid of that guy, I need to multiply by, let me change the color, let me put brown. I need to multiply by -4. -4 row 3 plus row 1 will give me new row 1. Okay, so let's do the green part first so it doesn't get confusing after that. Okay, so just keep in mind that we want to get rid of -5 first. Okay, and we said this is green, right? So what the first thing is going to change is row 2. So let's erase this. And I need to multiply row 3 by 5. Every element in row 3 by 5, and then add to row 2. So if you do that, 5 times 0 is 0, plus 0 is 0. 5 times 0 is 0, plus 1 is 1. 5 times 1 is 5. 5 minus 5 is 0. 5 times 2 is 10. 10 and -13 is -3. So I achieved that row 2. Now the next step, everything will remain the same except the first row, right? And my goal is to get rid of that 4. Therefore, I'm gonna erase row 1 because everything will remain the same except row 1, right? So I claim that I need to multiply -4 row 3, which is this part right here. Sorry about that. This part right here. I need to multiply -4 times that row plus the first row, right? That's what I'm doing. So we can do that, right? So -4 times 0, if let me do that one step at a time. I don't want to confuse you. 1, 3, 4, 3. So let's do that, right? So -4 row 3. So -4 times 0 is 0. Plus row 1, which is 1, it would be just 1, right? -4 times 0 is 0. Plus row 1 is 3. -4 times 1 is -4. -4 plus 4 is 0, so this 4 goes away. -4 times 2 is -8. -8 plus 3 is -5. Yes? Now, what's left over? What non-zero entry is left over? The only non-zero entry besides the ones and the zeros is that 3 right here, right? Above the pivot, this one, right? So let me put that in another color. Let me put that in, I don't know. Let's see, we have here this color. I need to get rid of that. So how can I do that? Well, you look at the pivot in the the second row. You can multiply the second row times -3 to get rid of that element in the first row. So I'm gonna multiply, let me put that in another color. So let's see, black. Okay, so -3 row 2 plus row 1 will give me new row 1. So let's do that. Remember, I want to get rid of that 3 though. Therefore, everything else change. Everything else change except everything else. I'm sorry. Everything else remains the same except row 1. So we can get rid of this, right? Or if you want, let's keep it like that for you to see the calculation. So as I claim, -3 times 0 is 0, plus 1 is 1. -3 times 1 is -3, plus 3 is 0. So finally I get rid of this, right? So we can put this in black. And then -3 times 0 is 0, plus 0 is 0. -3 times -3 is +9. 9 minus 5 is 4. So now you have the system of equations in reduced row echelon form. And this is called reduced row echelon form, right? I get the pivots on the diagonal. I have 0 entries everywhere, and that's the goal, right? So if they're asking me what's the answer for this problem, it will be x, y, z. As if I write it as a vector form, my solution, and my answers will be, wait 1 second, 4, -3, and 2. So this is the answer for this problem. Okay, I hope you understand this. This is not too difficult, but you need to follow the steps through. And I think the way I did it, I think it's kind of easy. I don't know if it's 100% easy for you, but try to practice as much as you can. You don't need to watch all this video, but I'm just doing it just in case you need more practice, right? So I'm gonna do one more. It takes time. It takes some time. And after that, when you get it, you can do it faster. The reason I'm taking a little longer time is because I'm explaining to you very slowly. Usually, it doesn't take me that long. It probably take me like 2 minutes or 1 minute. But I just want to make sure that you understand. Okay. Again, what's the goal? The goal is to get the identity matrix, right? 1 0 0 0 1 0 0 0 1, right? And once I have that situation, I will have my values x1, x2, x3 in this case, right? So this is the goal. Just to make sure that the variables, oh, okay, this is not x, y, z. This is just in case. They label this x1, x2, x3, just in case, okay? Now, so again, I need to write this system of equations as a method matrix. So I have to do this. So this is 2, 8, -4, 2, 11, 5, 4, 18, and 3. And this is 0, this is 9, and this is 11. Okay, so now I have a problem, right? I don't have the 1 usually in this position. I don't have the 1 there. Or let me put it this way. Usually I want a 1 in that position, right? But I don't have it this time. I have a problem. However, that's not a big deal because you know that all these numbers you can divide or multiply by one half, because all are divisible by 2. 2 is divisible by 2, 8 is divisible by 2, -4 is divisible by 2, and that's good news for me. So what I'm gonna do is I'm gonna multiply, before I even attempt to do anything, I want to get always the 1 in the first entry in the matrix, right? So I'm gonna multiply 1/2 row 1, right? And that will give me new row 1, right? Once I do that computation, that will give me row 1. So this is what's gonna happen. So everything else remained the same, as I mentioned. Everything else remained the same except row 1, right? So we delete this guy and we do the computation. So if you multiply 1/2 times row 1, that would be 1/2 times 2 is 1. 1/2 times 8 is 4. 1/2 times -4 is -2. 1/2 times 0 is 0. Now I have a 1. Do you see this? That's a 1. That's what I want, and that's what they have here. Okay? Hope that makes sense. Now, what's the next step? Now that I have the 1, it's easy for me to do the multi-step, like the 2 steps at a time. So I'm gonna do -2 row 1 plus row 2, and this will give me new row 2. And then the same logic applies for the third row. So I'm gonna do -4 row 1 plus row 3, and this will give me new row 3. Sometimes when I'm in the class, I don't have enough time, so I have to rush it. Now I have the time, so I can go slow, right? So let me fix this for you. So this is copy and this is paste, right? And so let's take care of the second row first. So everything on the second row will change, except yeah, everything in the second row will change. Everything else remain fixed. So for the second row, I need to multiply -2 row 1 plus row 2. So if you look back here, right? We're doing this, right? You multiply -2 times all the elements in row 1. So -2 times 1, -2 plus 2 is 0. -2 times 4 is -8. -8 and 11 is 3. -2 times -2 is +4. And 5, that makes a 9. -2 times 0 is 0. Plus 9 is 9. So that's what we have now. Now, can I get rid of the last row? Of course, right? So now the next step will be the row 3. So everything in row 3 change, everything else remain fixed. So if we do -4 times all the elements in row 1, right? Yeah, so that's what we need to do next. So -4 times 1 is -4, -4 plus 4 is 0. -4 times 4 is -16, -16 and 18 it's 2. -4 times -2 is +8. 8 and 3 gives you 11, right? -8 times 0 is 0, plus 11 is just 11. So that's why you have so far. Now notice one thing in the second row we can multiply by 1/3, right? We can do that computation. So let's multiply that by 1/3 here. So let me multiply 1/3 row 2 will give me new row 2. Yes. So let's do that. So remember, only thing is changing is row 2, right? Everything else remains the same. So let's do that. So this is 0, 1, 3, and 3. Okay. So now we have, as I mentioned before, the goal it's to have zeros below that 1 in the first entry, right? So we have zeros below that 1. So that goal has been achieved, right? Now what's next? What's next is, and remember these are equivalent expressions, right? What's next is try to get rid of okay, now that we have that, we can get rid of this guy, right? We should get rid of that guy. So let's see what happens after that. So if we multiply, let's see, if we multiply -2, row 2 plus row 3, this will give me new row 3, right? Because I'm trying to get rid of that too. So let's do that. Oh. I don't know what happened. Okay. I'm sorry about that. I don't know how that happened though. So what's going on? Okay, here we were doing this, right? Yeah. So I was telling you that I want to get rid of that 2 here. I want to get rid of these 2 here, right? And in order for me to do that, so I'm gonna multiply. I was mentioning before. Let's see what happened because. Okay, so we need to multiply this by -2, row 2 plus row 3, and this will give me new row 3, right? The only thing is changing is that position, that row with the 2. So I'm gonna erase this because that's changing. So you do the multiplication, right? -2 times all the elements in row 2, so -2 times 0 is 0, plus 0 is 0. -2 times 1 is -2, -2 plus 2 is 0. -2 times 3 is -6, -6 and 11 is 5. -2 times 3 is -6, and -6 and 11 is 5. So now you see how nice this turns out to be, right? So now we can, again, multiply by 1/5 row 3, right? So if we multiply by 1/5 row 3, we get new row 3. Okay, so again, everything is fixed except what? Except that that row 3. So if we divide by 1/5, 1/5 times 0 is 0. 1/5 times 0 is 0. 1/5 times 5 is 1. 1/5 times 5 is 1. So that's what I have so far. So now this is in row echelon form. Okay. Now, what's next? They ask for Gauss-Jordan elimination method, right? So I need to get rid of these entries. I need to get rid of this, I need to get rid of this, and I need to get rid of that. Basically, I want to have zeros in those positions, right? Sometimes they call that, this matrix as it is right now, it's called upper triangular. So they want me to get rid of those 3 entries above the diagonal. Sometimes they call that the lower triangular, right? Not sometimes, all the time. So let's get rid of that. So my first goal is to get rid of these 2 guys, right? So I'm gonna do the multi-step, okay? The multi-step. So I'm gonna do first, let's see, -3 row 3 plus row 2, that will give me new row 2. And then I will do negative, 2 row 3 plus row 1, and that will give me new row 1. Okay, so that's what I'm trying to do. I hope you understand. So copy and paste. So the first thing is I need to get rid of the second row, right? So that means that this row is going to change. So this is going to change. So if we do the computation, -3 times all the elements in row 3. So -3 times 0 is 0 plus 0 is 0. -3 times 0 is 0 plus 1 is 1. -3 times 1 is -3. -3 plus 3 is 0. -3 times 1 is -3 plus 3 is 0. Okay, that's nice. Now I need to get rid of what? I need to get rid of that -2, right? I need to get rid of that -2. So what's changing is the first row. So I'm gonna erase the first row here and let's compute that. So negative 2 row 3, right? So 2 times all the elements in row 3. So 2 times 0 is 0 plus row 1 is 1. -2 times 0 is 0 plus 4 is 4. -2 times, I'm sorry, 2 times 1 is 2. 2 minus 2 is 0. 2 times 1 is 2 plus 0 is 2. Yes? So that's what we have so far. So again, I multiply 2 times all elements in row 3, and then I add row 1. So 2 times 0 is 0 plus row 1, which is a 1 here, it's 1. 2 times 0 is 0 plus 4 is 4. Negative 2 times row 3, or in this case 1 it would be, right? 2 times 1 is 2, minus 2 is 0. 2 times 1 is 2, plus 0 is 2. So that's what we have so far. Now, the next target will be try to get rid of this number, right? Because that's the last non-zero or 1 entry, right? So I need to get rid of that. So how can I do that? That's the question. Very simple. I need to multiply -4 times row 2. So -4 row 2 plus row 1, and that will give me new row 1. And once I achieve that, then I'm done with the Gauss-Jordan elimination, right? So let's do that. So the only thing is changing is row 1, right? So let's compute. So -4 times 0 is 0 plus 1 is 1. -4 times 1 is -4 plus 4 is 0. -4 times 0 is 0 plus 0 is 0. -4 times 0 is 0 plus 2 is 2. I'm done, right? At this point. So I need to write this in matrix form as a vector. So this is my solution: x1, x2, x3 equals to, give me 1 second. So this is 2, 0, and 1. And this is the answer for this problem. Okay, that's the answer. I hope you understand. Okay. As you can see, these answers are consistent with what we're doing, right? So we have 201, just in case you want to check. So this is 201, and hopefully I didn't make any mistake. That would be bad at this point. So this one is 483 too, and what is that? 483 too, same thing, right? So let's do 2 more, and that's basically it. And again, if you feel like, oh, I got this, you don't need to watch this, right? I mean, if it's too long. Again, what's your goal? Your goal is to get the identity matrix, right? The identity matrix. Okay. Okay. So let's do the computation. So again, let me just in case, let me write the identity matrix just for visual purposes. Maybe you still need to visualize what's going on. Remember, this is x1, x2, x3. I hope you understand that. Okay. So now what's next? So what you need to do is you need to write the system of equations as a matrix. So this is, there's no x1 in the first equation, just in case. This is the first equation, this is the second equation, this is the third equation. Let me change the colors just in case somebody's confused. So let me put that in this color, and then this in this color. So we have three equations, right? I'm talking about the first one. The first one, there's no x1 entry. So I have to put a 0 here, 0, 2, 6. And I have to put the augmented matrix. So this is 2. So for the second equation, we have 3, 9, 4, 7. And for the last or third equation, we have 1, 3, 5, and 6. Okay. So what I need to do, I can do a row exchange, because look at this entry right here. I have a 1 here, right? So I'm gonna do a row exchange. So I'm gonna do row 3 exchange with row 1 to get new row 1, right? That's the whole point of doing this. So let's do that. So again, these two, they're gonna change, right? Row 3 and row 1. So those are changing spots, right? So we have 1, 3, 5, 6, and then we have 0, 2, 6, 2. Now, if you pay attention closely, I could do multi-step, right? Because I can actually change row 2 with row 3 to get the 0 under that one, to get this form, right? To get this form, right? To get the zeros there, if I switch row 2 with row 3, then I will have a 0 in the position desired. So I will do again a row swap, right? So I'm doing row 2 swap with row 3 to get a new row 2. So I will do that here. So those two, they change position now. So this is now 0, 2, 6, and 2, right? And we have 3, 9, 4, and 7 here when I do the row swap, right? Now you have a 0 in the position desired, so you need to get rid of this guy right now. You have that 0 there, so you're done with that. Now you need to get rid of that, of the last, this 0 right here. We need to get rid of that 3. So how can we do that? Very simple. Multiply the first row by -3. -3 row 1 plus row 3 give you new row 3. That's what you're gonna do, right? These are equivalent just in case. So let's do that. Remove this a little bit here so it doesn't get messy, this thing. Okay, so that's what I did. So everything remains the same except row 3. So let's do the computation. So -3 times all the elements in row 1. So -3 times 1, -3. -3 plus 3 is 0. -3 times 3 is -9. -9 plus 9 is 0. -3 times 5, -15. -15 and 4 is -11. Then you have, let's see, 83 times 6 is -18. -18 and 7, that will give you -11. Now you can see clearly that you can divide the row 3, or you can divide by -11, or you can multiply by -1/11, right? So let's do that. So let's multiply. So -1/11 times row 3 will give me new row 3. So let's do that. Remember, these are equivalent expression and matrices. And let's copy, paste. Okay, so let's get rid of the last row. So if we multiply by -11 row 3, we get -11 times 0 is 0. Negative 11 times 0 is 0. Negative 11 times negative 11, that will give you 1. Negative 11 times negative 11, that will give you 1. So I have now row echelon form, right? So now I need to get rid of the numbers in the upper and the lower triangular. So I'm talking about these things right here, right? And if I do that, then I'm happy, right? But before we do that, notice that in row 2, I can divide or I can multiply everything by 1/2, right? So if you do that, if you multiply everything by 1/2 on row 2, you get new row 2, right? So let's do the computation. So what's changing? Row 2 only, right? So this is gonna change. So and the claim was that I need to multiply by 1/2. So 1/2 times all the elements in row 2. 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 6 is 3. 1/2 times 2 is 1. Now it's easier for me to compute, right? So let's do the multi-step way that I was showing you before. I need to get the zeros there. So the first thing I'm gonna do is I'm gonna try to get rid of those zeros above the 1 on the third row, right? So let's start with that. So let's do negative 3, row 3 plus row 2 will give me new row 2. That's the first one, right? And then we can do, let me change the color. So we can do negative 5, row 3 plus row 1 will give me new row 1. Okay, so let's do this. This computation, copy, paste. Now what's changing? Everything in row 2 will change. So let's get rid of that. Okay, so negative 3, row 3 plus row 2. So all the elements in row 3, they're gonna be multiplied by negative 3. So negative 3 times 0 is 0, plus 0 is 0. Negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 1 is negative 3, and 1 is negative 2. Yes? Now what's changing now is the first row, right? And I need to do the same, basically similar procedure, right? I want to get the 0 there. So yeah, let me put the same color before somebody get confused. This is, yeah, this color. Okay, the last one, right? So negative 5, row 3 plus row 1. So all the elements in row 3 multiply by negative 5. So negative 5 times 0 is 0, plus 1 is 1. Negative 5 times 0 is 0, and 3 is 3. Negative 5 and 1 is negative 5. Negative 5 plus 5 is 0. Negative 5 and 1 is negative 5, plus 6 is 1. So I'm almost done. The only thing I need to do is get rid of the last entry that is not a 1 and that is not a 0, right? Which is these 3 right here. And if I can do that, and then I achieve Gauss-Jordan elimination, right? So let me multiply this by row 2 by negative 3, right? So negative 3, row 2 plus row 1 will give me new row 1. So let's do the computation. Copy, paste. So what's changing now is row 1. And I need to multiply negative 3 times row 2. So negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 and 0, or negative 3 times 0 is 0, plus 0 is 0. Negative 3 times negative 2 is positive 6, plus 1 is 7. So now I'm done. So this is the answer for the system of equations. So x1, x2, x3 equals, let me copy this, it's easier for me. Then we can get rid of these things, right? And then what's the answer? The answer will be 7, -2, and 1. And this is basically the end of this problem. Okay. Let's do the last one. I hope you understand this. Let's do one more. And let's check the answer too, because I can make mistake too. So we have, this is answer, right? For this problem. 7, -2, and 1. Let's check. 7, -2, and 1. So that's correct. Okay, let's do the last one. So this is killer, right? The last one is a 4x4. But it's the same thing. Don't worry, we're gonna get it done. Again, I'm gonna go faster this time. I hope you can follow through at this point. So again, now I need to get 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Once I achieve that, I get x1, x2, x3, x4. So that will be my solution for that problem. Okay, so let's compute this. So first step, remember this is the goal, right? If you still confused, this is the goal, is to achieve that. Okay, so let's do that. So we have to write this as an augmented matrix. So let me put that here. And we have 1, 3, 2, 5, 11, -1, 2, -2, 5, -6, then 2, 6, 4, 7, 19, 0, 5, 2, 6, 5, and I need to write this way. Okay, again, I have a 1 in the first entry, so I'm good, right? That's good. So I can solve this really fast. So my goal is what? My goal is to have zeros here. My goal is to have zeros here. You see? So my target is these 3 guys. I have to make them 0, right? So we can do multitasking here. We can do row 1 plus row 2, give me new row 2. And you say, why you didn't multiply this time? Because 1 and 81, they're opposite of each other. So I don't need to do anything. I don't need a multiplier. So that's the first step. For this, then after that, I can get rid of this guy. So I need to multiply 1 by -2. So -2, row 1 plus row 3 will give me new row 3. So done with that step 2. Now what's next? I have a 0 there. So I'm lucky. I'm lucky, right? I don't need to do anything there. We can do a row swap if you want. There's no wrong or right move. It's just about how you do it, right? But there's no wrong move here. So it's up to you what you want to do first or second or whatever. As long as you get the basic steps, then that's fine. So now let's do that. Let's copy this and paste, copy, paste. Okay, so now what's changing is row 2, right? For the red part or the red step. So we're changing this. So let's do the computation. Change the color because then after that you're gonna get confused. So let me put a different color. Let me do that in pink. Okay. So row 1 plus row 2, 1 minus 1, 0. Right? 1 minus 1, 0. 3 plus 2 is 5. 2 minus 2 is 0. 5 plus 5 is 10. And 11 and 86 is 5. Okay. What's next? Get rid of this guy, right? These 2 here. So we did that already. So that's the purple step. So let me erase this stuff. And we need to get a new row 3, right? So if we do that, so we do -2 row 1 plus row 3. So -2 times all the elements in row 1. So -2 times 1 is -2 plus 2 is 0. -2 and 3 is -6 and 6 is 0. -2 times 2 is -4 and 4 is 0. -2 and 5, -10 and 7, -3. -2 and 11 is -22 and 19 is -3. Okay. So as you can see, we can divide row 3 by -3, or we can multiply -1/3 times row 3, which is the same, right? So we can do that step. Let's do that. Let's say that that's -1/3. Let me make it a little smaller so I can have room to write this thing. So I can say -1/3 row 3 will give me new row 3. So what's changing? The only thing is changing is row 3. Okay, so row 3 is changing. So remember, we're just multiplying -1/3 times all the elements in row 3. So this is 0 because -1/3 times 0 is 0. -1/3 times 0 is 0. -1/3 times 0 is 0. -1/3 times -3 is 1. -1/3 times -3 is 1. Now, I can do a row exchange, right? Because we need 0, 0, 0, 1 in the last row. So I'm going to do a row exchange here. So I'm going to do row, let me put that in a different color. I said I'm going to do a row exchange. Let's do that in green. So row 3 swap with row 4, and that will give me new row 4. Okay, let's do that. So let's do that. So what's changing is both. I need to erase both of these, right? Because both are changing position. And we need green here. So now this is 0, 0, 0, 1, 1. And then that row 3 becomes, that row 4 now becomes row 3, right? So this is 0, 5, 2, 6, 5. Okay. Now, what's my goal? No, look, if you look at row 2, I could do a multi-step here. I can divide row 2 by 5 or multiply by 1/5. So let's do that. So let me change the color. Let me put that in this color. So let's multiply 1/5 row 2, and that will give me new row 2. Okay. So what's changing? The only thing is changing is this guy right here. So let's divide. Let's multiply that row 2 by 1/5. So 1/5 times 0 is 0. 1/5 times 5 is 1. 1/5 times 0 is 0. 1/5 times 10 is 2. 1/5 times 5 is 1. So that looks a little better, right? Now let's see what else can we do. So let's see. So the next goal will be, we can get rid of, let's see what we can do to make it life easier. So look, you can do this here, right? You can get rid of that 2 first. Why? Because once I have that 2, then I will have the identity in the second row. That's why I'm doing that. Okay, I'm sorry about that. So here I need to multiply row 4 by -2. So it's probably a little longer, right? It's not too simple. Let me erase that. This is 11. So let's multiply row 4 by -2. So -2 row 4 plus row 2 give me new row 2. So let's do that. Okay, so we're gonna get rid of row 2 because that's the thing is gonna change, or that's the row that's gonna change. So -2 times all the elements in row 4. So -2 times 0 is 0 plus 0 is 0. -2 times 0 is 0 plus 1 is 1. -2 times 0 is 0 plus 0 is 0. -2 times 1 is -2 plus 2 is 0. -2 times 1 is -2 plus 1 is -1. Okay, so now we're done with that. So what's next? So we have many options, right? We can do too many things. Let's see what we can do next. You can, if you want, you can get rid of these 5 now at this point. This guy right here, right? We can get a 0 there, and that would be nice if we can get a 0 there. Let's do that. So we need to multiply. Let's see, let me put that in blue. So we need to multiply -5 row 2 plus row 3, and that will give me new row 3, right? So let's do that. So what's changing is row 3, right? Row 3 is gonna change. So I can get rid of this. Okay, let's do the multiplication. So -5 times 0 is 0 plus 0 is 0. -5 times 1 is -5 plus 5 is 0. -5 times 0 is 0 plus 2 is 2. -5 times 0 is 0 plus 6 is 6. -5 times -1 is +5, and 5 is 10. Right? So now we're almost done. I can divide everything by 2 in row 3, right? So let's do that. So divide, let me do that in another color. So divide row or multiply by 1/2 row 3 to get new row 3. Okay, so let's do that. I'm sorry if it's taking long, but you know I'm explaining to you. It takes time, right? It's not when you explain it. When you do it by yourself, it nothing, 1 minute or maybe a little bit more, but it doesn't take this long. Okay, so now what we need to do is we need to get rid of row 3 because that's the one that is changing. So we need to multiply that row 3 by 1/2, so that's 0. Row 3 times, 1/2 times row 3 is 0. 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 3 is 1/2 times 6 is 3. 1/2 times 10 is 5. Okay. So what's next? I need to get the zeros here, and here. So we can do multi-step because we have a pivot on the last row, and that's pretty easy to do after that. So let's see. We can multiply -3 row 4 plus row 3, and that will give me new row 3. That's one step. And the next step will be let's see what color we can put. We can do -5 row 4 plus row 1, and that will give me new row 1. So let's do that. Copy, paste. So the first thing I'm gonna try to do is I'm gonna try to eliminate row 3, right? So let me change that because that's changing, and that's in blue. So -3 times all the elements in row 4 plus row 3. So -3 times 0 is 0 plus 0 is 0. Negative 3 times 0 is 0, plus 0 is 0. Negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 1 is negative 3, and 5 is 2. Okay, good. We're done with that step. Now we have to do the purple step. So what's changing? Row 1. So we change row 1. We erase it because that's what's changing. So negative 5 times all the elements in row 4 and then add row 1, right? So let's do that in purple. So negative 5 times 0 is 0, plus 1 is 1. Negative 5 times 0 is 0, plus 3 is 3. Negative 5 times 0 is 0, plus 2 is 2. Negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times 1 is negative 5, plus 11 is 6. Okay? So what's next? So next is to get rid of all the elements that have not 0 and 1s, right? So we have here 2 guys, right? So how can we do that? We can take care of them at the same time. So let's see what we can do. Let's see. Let's for the 2 that is in green right now, I'm talking about this guy. I'm gonna multiply negative 2 row 3 plus row 1. So negative 2 row 3 plus row 1 will give me new row 1, right? So in this case, I'm going to do step by step because it's a little tricky, okay? I don't want to confuse you. Actually, we can do that all the time at the same time. That's okay. Okay, let's do, and then we can do negative 3 row 2 plus row 1, and that will give me new row 1. Okay, so let's do that. And then after that, we're done, I think, hopefully. We're done with this problem after that. Copy, paste. So now let's erase row 1 because that's what's gonna change. Okay, so let's take care of the black step first. So negative 2 times all the elements in row 3 plus row 1. So negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 0 is 0, plus 3 is 3. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 is 0, plus 0 is 0. Negative 2 times 2 is negative 4, and 6 is 2. So that step is done. Now I need to get rid of the 3, right? But that's not a big deal because we said that we're gonna multiply negative 3 times row 2 plus row 1 to get rid of that 3. And when I'm talking about this 3, I'm talking about this guy right here. Okay, so let's do that. So I need to erase one more time row 1. And let's do that in this color. Negative 3 times all the elements in row 2 plus row 1. So negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 0 is 0, plus 2. Oh, well, that 2 doesn't exist anymore. Yeah, that 2 doesn't exist anymore. Because I get rid of that, right? Hold on. Okay, let me go back because I did something. It's right, but it's just hold on, give me 1 second. Let's see what's going on. I'm sorry about that, but I just want to make sure that I give you the right answer. Okay, so we were saying that we need to get rid of those numbers, right? 2 and 3 in green. So when I'm talking about these two. So you can multiply the row. Let's do one step at a time, like I said before, just to play safe here. So let's do -2 row 3 plus row 1, and that will give me new row 1. Okay, so let's do that. So let's do that. So copy, paste, and what's gonna change, as I said before, is row 1, so I can erase all this stuff. Okay, so let's do that. So -2 times all the elements in row 3. So -2 times all the elements in row 3 plus row 1. So -2 times 0 is 0, plus 1 is 1. -2 times 0 is 0, plus 3 is 3. -2 times 1 is -2. -2 plus 2 is 0. -2 times 0 is 0, plus 0 is 0. -2 times 2 is -4, and 6 gives you 2. So that's okay. Now we can get rid of that last element, which is that 3, right? So we need to multiply. Row 2 by -3. So -3 row 2 plus row 1 will give me new R1. So let's do that. And then we're done, right, with this problem. So let's do that. So row 1 is going to change one more time. And we're multiplying -3 times row 2. And then add row 1. So -3 times 0 is 0, and 1 is 1. -3 and 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 0 is 0. -3 times 0 plus 0 is 0. -3 times -1 is 3. 3 and 2 gives you 5. So that's the answer for this problem. So x1, x2, x3, x4 equals. Let me copy this one here. I don't want to keep writing this thing. They're annoying. Okay. So this part. Perfect. This is equal to. So 5, -1, 2, 1. Okay, let's change the color because that's the answer. So that's it. That's the answer for this problem, right? So let's let me double check my solution. So you have 5, -1, 2. Hopefully that's right. So this is answer for this problem. Hopefully we get it right. If not, then I can fix it. That's not a big deal. So they got the same as I do. So I'm done with this problem, and I'm done explaining to you too. I hope you're happy while I take the time to do all these things. If you're still confused, please ask tomorrow during class, okay? So that's it. Have a good night. And please watch this video because I spent so much time trying to explain it to you, okay? Bye.